The observable universe refers to the part of the universe that we can see and observe. This includes everything within a sphere around Earth with a radius of about 46 billion light-years. However, this is just a tiny fraction of the entire universe. In fact, some theories suggest that the universe could be 250 times larger than the observable portion, or even infinitely large. What lies beyond the cosmic horizon of the observable universe remains one of the biggest mysteries that scientists are trying to uncover. Here are 5 leading theories that attempt to explain what may exist in the vast realms beyond what we can see in the night sky. Theory 1. An infinite universe. One possibility is that the universe just keeps going on forever. Many astronomers believe that the distribution of galaxies continues uniformly far beyond the part we can observe. So, if you were to travel 46 billion light-years away from Earth and look around, you would see a universe looking much like our own, with galaxies and galaxy clusters extending outward endlessly in all directions. This infinite universe model is based on the idea that the universe is geometrically flat on the largest scales, rather than curved like the surface of a sphere. Observations of the cosmic microwave background radiation by satellites like WMAP and Planck lend support to this theory, indicating that the geometry of space-time is essentially flat. A flat universe can theoretically extend forever, rather than looping back around on itself like a spherical universe. However, we cannot know for certain that the universe is infinitely large based on current evidence. It is also possible that the universe is finite but much larger than the observable portion. But the possibility of an endless spatial expanse beyond our horizon is intriguing. The universe may contain an immeasurable number of galaxies, stars, planets, and even civilizations that we will never know about. The scale of an infinite universe is staggering to contemplate. Theory 2. A finite spherical universe. Another possibility is that rather than being flat, the universe is curved in the shape of a 4-dimensional sphere. This would mean that while the universe has no edges, if you travel in one direction long enough, you would eventually return to your starting point. In a finite spherical universe, no matter which direction you look, if you peer far enough, you would end up seeing the back of your own head. Light could travel all the way around such a universe if given enough time. The circumference of the entire universe may only be about 250 times greater than the observable portion. The spherical universe concept depends on a positive curved geometry indicated by the density of matter and energy in the universe. If the density is above a certain critical threshold, called the critical density, then space-time can curve back on itself like the surface of a sphere. Some supercomputer simulations have modeled a finite spherical universe, consistent with observations. While possible, a spherical universe is not currently favored by most cosmologists. Data from satellites points towards a flat or open infinite universe as the more likely scenario. But improved measurements in the future could potentially provide evidence for a spatially wrapped universe on the largest scales. Theory 3. A multiverse of universes. Perhaps even more mind-bending than the concept of an infinite universe is the possibility that our universe is just one in an infinite multiverse. The term multiverse can have different meanings in physics and cosmology, but one common definition is that infinite alternate universes exist parallel to our own. These universes could potentially have fundamentally different physical laws and characteristics than what we observe. The idea of parallel universes arises from interpretations of quantum mechanics applied to cosmology. According to quantum theory, vacuum fluctuations cause virtual particles to briefly blink into and out of existence. Some physicists think this quantum fuzziness could give rise to entirely new pocket universes that grow to infinite size. These daughter universes would be fundamentally disconnected and unable to interact with each other. In the context of inflationary theory, different regions of space-time may have undergone inflation at different rates immediately after the Big Bang. This could have caused areas of the primordial universe to separate and evolve into distinct realms. The result could be an eternally reproducing multiverse. While alluring, the concept of parallel universes remains highly speculative and must overcome major theoretical challenges. Other physicists interpret quantum effects differently or dispute the extrapolation of quantum theory to such cosmic scales. But investigations into the foundations of cosmology continue, leaving open the thrilling possibility of additional dimensions or layers to reality that we remain unaware of. Theory 4. Unknown new physics at cosmological scales. When theorizing about the vast realms beyond our observable cosmic horizon, the possibility of new physics cannot be excluded. The universe appears to follow familiar physical laws, like gravity, electromagnetism, and thermodynamics, at least in our local vicinity. But remarkably, 96% of the universe is composed of dark matter and dark energy that remain mysterious to us. And the immense scales of the whole universe may be enormous enough for unfamiliar physical phenomena to emerge that have no manifestations locally. For example, our current physics models break down infinitesimally close to the singularity of a black hole. Likewise, new properties of the universe could emerge on ultra-large scales beyond our perception. Perhaps in the vastness beyond our horizon, contradictions emerge between quantum mechanics and general relativity that lead to completely unexpected consequences. Or long-range quantum entanglements may form that fundamentally alter concepts of locality and space-time. Freak macroscopic quantum effects could occur at universe-wide scales. In other words, the laws of physics as we know them may be just a locally valid approximation for phenomena occurring in our cosmic vicinity. The search continues for a unified theory of everything, which could reveal what new physical rules govern on the largest cosmological scales. Theory 5. It's all an illusion. Cosmological natural selection. This theory takes an even more radical approach to cosmology that borders on the metaphysical realm. Called cosmological natural selection, it proposes that universes propagate like living systems. In this view, the universe undergoes eternal self-replication, with quantum events giving birth to new universes via black holes. Physicist Lee Smolin first developed cosmological natural selection as an alternative to traditional multiverse hypotheses. Similar to biological natural selection, black holes represent the reproductive organs of universes. When a black hole forms, it spawns a new universe with randomly adjusted physical parameters. Universes optimized for producing more black holes have an advantage in propagating offspring universes. These descendant universes are not separate from our existence, but rather extend beyond it. Reality, therefore, is like an infinite succession of dreams, ordered by what maximizes reproductive potential. But each universe is an illusion. Only the eternal cosmic natural selection process itself lies outside of space and time. While highly speculative, this evolutionary concept pins the emergence of physical laws to what produces abundant black holes. It is an attempt to explain why our universe appears surprisingly optimized for complexity. However, the theory remains fringe and lacks broad observational support from cosmologists. Beyond the horizon of what we can see, the universe extends much further than we may imagine. Trillions of undiscovered galaxies may populate its vast expanse, or reality itself may take on unfamiliar dimensions. The mysteries lurking beyond our cosmic view stoke our imaginations, and with advancing technology, more of the universe's secrets may gradually come into focus. What we know for now is that the observable universe is only a tiny island in a potentially limitless grand cosmic ocean. Our glimpse of reality is but a faint keyhole view into infinities waiting to be explored. Don't forget to like and subscribe to our channel so you don't miss new videos.